Just like with ellipses, sometimes we get the equations in general form, not standard form like we have here. And the easiest thing for us is going to be to change the form and then pluck out all of the pieces of information. So let's change this form. Okay, I'm going to, very similar to what we did with ellipses, I am going to put all the terms that have x, and then all the terms that have a y, and then put anything that doesn't have a constant with it, excuse me, a variable with it, to the other side of the equation. Okay. Now I'm going to factor. For these first two, oops, there was an x here. For these first two, I'm going to factor out a 9. And for the second two, I'm going to factor a -4. Okay. I'm going to complete the square here and here, so two different places. I want the x squared minus 4x plus something to be a perfect square. I'm going to take the middle term and cut it in half. X minus 2. I'm going to say that number, or that quantity, rather, squared. Okay, that's what I want. So what's missing from above? Well, if I multiplied this all out, I'm missing a +4. Okay, now that's not a +4 in the equation though, because there's a 9 out front. So technically that's a +36. So I'm going to come over here and I'm going to go +36. Okay, next one. I want this to be a perfect square. So I'm going to take the middle term, cut it in half. And if I multiplied this all out, what I'm missing in the line above it is that +25. Now, even though it's a +25 there, there was a -4 in front of it as a multiplier. So really what I'm doing to the equation is I'm subtracting 100. So I have to do that to the other side as well, right there. Okay. So now my equation looks like 9 times x minus 2 squared minus 4 times y plus 5 squared equals, and then if we do the math on this, let's see, 288 plus 36 is 324. Okay. Now, if you look back at your format for standard form for a hyperbola, I need it to equal 1. So I'm going to divide everything by 324. To get my 1. Okay, so I will have x minus 2 squared over 36, a y plus 5 squared over 81. Okay, when I simplify these, we'll get 81 there, and here we'll get 36 there. Okay, I like this. I can see that this hyperbola is going to be an open left or right because the x comes first. I can see that A is 6, B is 9. I don't know C. I do know, though, that the center is at 2, -5. And it opens right and left. Okay? So let's get a grid on here. Here is at 2, -5. R, 8, -5, and -4, -5. Okay? Got my center, got my vertices, co-vertices, and foci. 9 down puts me here. Those are the co-vertices. So I don't like labeling them, but 2, 4, 2, -14. All right, and then lastly is the foci. I'm running out of room here. Foci. From the center, we're going to go left and right. C units. I don't know C though, so let's find C. C squared is equal to 81 plus 36, which means C is going to equal the square root of 117, which is around 10.8-ish. So 2, here's 6, 7, 8, 9, 10.8-ish. There's a focal point. Ew. So I'm starting at 2, -5. So from the 2, I'm going to the right square root of 117, staying at -5 for height. The next one, I'm at 2, and I'm going to go left square root of 117 and staying at -5 for height. So I'm here, I'm going to go left about 10.8-ish. Am I going to run out of room? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I am. About right there. All right. Asymptotes is the last thing. Well, for this one, y minus -5, so +5, is equal to slope and then x minus 2, because the center is your h and your k. Slope, well, this was up b over a. So the slope is going to be positive or negative b over a, so 9/6, x minus 2. And I could simplify this. Positive or negative 3/2, x minus 2. There's my asymptotes. And that is this one. And this one. And then the graph of the actual hyperbola goes through the vertice, approaches asymptote. Like so. Here's all the pieces we were asked for. And the graph. All right. My last question that I have for my notes here, it's just application questions where we're going to throw this information into an equation and then answer the question if they have one. Okay. So the design line layout of a cooling tower is shown. The tower stands 179.6 meters tall. The diameter of the top is 72 meters. At the closest, the sides of the tower are 60 meters apart. This is your x-axis, and my center then is at 0, 0. Okay. That means that my vertices here and here are 60. Oh, no, it's 60 altogether, so 30. So this is 30, 0. So that means A is 30 units. Okay. Now, I don't know B, and I don't know C. Okay. I do know, let's see, what else do I know? I know this point is from center 36 units out and 79.6 meters up. Okay. Find the equation. Well, it opens right and left, so I know that it's going to be an x squared over a squared minus y squared over b squared equals 1. okay? Really, this equation is almost done. I just need B. Well, since they gave us a data point to work with, well, they didn't really give it to us, but it's shown. We're going to use that. If I plug in 36 for X, I have to get 79.6 for Y. And since those could go here and here, the only variable left would be a B squared, and I can solve for that. So let's do that so we know B, okay? Okay. Then we are going to solve for B. So a little bit of cleanup there, put 1 on the other side, 79.6 on the right. (1.44 minus 1). This will give me a 0.44 equals which means B squared equals, so B is 120.002 meters. So that means I can write my equation. X squared over 900 minus Y squared over equals 1. And there's my equation for this cooling tower.